All right. So anything that you take notes on, remember you can use on the test, which will be next Thursday, May the 13th. Okay. I wanted to talk really quick too. I'm sure on the Canvas page, you guys saw that there were 6 EOC assignments posted. They posted on your Canvas page on Saturday, May the 1st, open at 12 a.m. They are due Friday, May 21st by 1:45 p.m. Okay. Here's the stipulations with those. There's 6 assignments. Okay. We're going to do 3. The average of the first 3 is a formal grade. The average of the second 3 is a formal grade. Okay. You can use your notes, whatever that you need to do those. Now, there's 3 attempts on each one. Okay. So, you know, the concept of retesting, that's essentially what you're doing, right? Because you get 3 attempts. Now, you are not required to start them now, this week or next week, but you have them available to start if you would like. Starting May 14th, which is next Friday, I have a lesson associated with each EOC review. So we'll do 10 questions when you come in on Friday, May 14th. We're going to do 10 review questions that mirror the assignment EOC review number 1. Monday, the 17th, we're going to do 10 review questions together that mirror EOC review 2. Tuesday, you get my flow here. We're going to do like 10 review questions that mirror the assignment for the reviews. Okay? So you can start them now if you want to. By all means, that's why they're open and we gave you ample time. The due date says the 14th, but remember, because we have to give you that 5-day grace period, they are due by the 21st at 1:45, which is when all late work, all makeup work, all retests, all tests are due. Okay? Okay, let us get started with today's content. Let's do a warm up first from our circles unit that we just tested on yesterday. So the first thing I recognize and see here are those tick marks. And so remember that the tick marks are indicative of congruent chords. So this chord here is congruent to this chord here. And if you remember from our unit, because the chords are congruent, the arcs are also congruent. So what that means is W equals 78 degrees. Congruent chords have congruent arcs. Okay? We have here an inscribed angle. Let me highlight that in green. Remember, you heard this term a lot last unit. An inscribed angle will be half of its arc measure. So if the inscribed angle is 50, thank you. Mm-hmm. Yeah, thank you so much, though. Okay. If the inscribed angle is 50, then the arc would be what? 100 degrees. So y equals 100. Okay, the last thing that we want to solve for is x. So what we're going to do is we're going to add up the arc measures that we have. 78 plus 78 is 156. 156 plus 100 is 256. Take 360, subtract 256, and it means that the missing arc is what measure? 104? 104. Okay, so if this arc is 104, that looks like a funny 4. Let me fix that. If this arc is 104, what would this angle then have to be? 52. So to find x, we're going to go 6x plus 2 equals 52. Subtract 2, 6x equals 50. Divide by 6. X equals, what is that, 25 thirds? We'll leave it like that. Divide 56 by 2. Divide by 2 top and bottom, 25 3/3. Okay? All right, here we go. First notes that we want to write down. Okay, so you're going to hear quite often in this unit the idea of an initial side and a terminal side. So when an angle is created in the coordinate plane, the initial side will always start on the positive x-axis. Okay, so the initial side is here. Okay, there's your initial side. If it is a positive angle of rotation, so if theta is positive, you are going to move counterclockwise. Okay? Positive angle counterclockwise. Let me write that down. Okay? So the terminal side is where the angle's like ending side lands. Okay? Positive. So we start 0, 90, 180, 270, and of course come full circle at 360. Okay, initial side is always on your positive x-axis. You have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you have a negative angle of rotation, okay, funny, yes, you can measure negative with theta. If you have a negative angle, you will move clockwise. Negative is clockwise. Okay? Your quadrants still remain the same. Okay? Your quadrants still remain 1, 2, 3, 4 on the coordinate plane. Except we're going negative 90, negative 180, negative 270, and then of course negative 360. Right? You're going clockwise around. Lowercase Greek letters such as alpha, beta, gamma, and theta are used to name trig angles. So if you see those funky looking letters, those indicate to you the unknown measure. Okay, or the measure, if you do know what it is. Okay, I'm going to give everybody a couple minutes. Make sure you have down positive angles go counterclockwise, negative angles go clockwise. You always start your initial side on the positive x-axis. Your terminal side is where the angle ends. So if I told you to draw a 130-degree angle, which quadrant would you end up in? 130 degrees. Where are you landing? Quadrant 2. 0, 90, 180. Look at your quadrantals, right? Your x and y axis. 0, 90, 180, 270, back to 360. Okay, does anybody need more time here? Need more time? Yep, take your time. Now, most often, you'll see theta. That's like most often used. Sometimes when you get into the higher level mathematics, they use alpha and beta. I really never see gamma. I got my math stuck in my earring. Okay, let us keep going. Are you good? Okay. The next thing we're going to talk about are the idea of coterminal angles. Okay? The definition is angles in a standard position with the same terminal side. For example, a 120-degree angle and negative 240 degrees are coterminal. There are infinitely many coterminal angles. One way to find the measure of an angle that is coterminal is to add or subtract multiples of 360. And that's what we're going to work on first. The concept of coterminal. Because even if you put your pointer finger in the air and start drawing a circle, you can just keep going, right? Like we understand that the circle can keep going and going and going and going. So when you have an angle and you draw it in the coordinate plane, that angle, wherever it stops, you can continue, you can add 360 to it, and then get another terminal side that lies with it, and do it again, and do it again, and do it again. Okay? So coterminal angles are infinite, but we're going to work on finding one positive and one negative. Okay? So if I drew in the coordinate plane 120 degrees like is shown, and then if I drew negative 240, they would stop at the same exact point. That's what coterminals are. Co-terminal. Co means with, terminal is end, so they end at the same spot. Does anybody need more time on this screen? Good? Okay. Oh, nope, not good. Okay, just send me a message through when you're ready to go. Okay. Okay. Find two coterminal angles to each measure, one positive and one negative. So we're going to start with the first one, which is negative 98 degrees. Okay, it's in a degree measure. So to find a positive coterminal, I'm going to add 360. So I'm going to add 360. Okay, negative 98 plus 360. Because it's a little early, I can't do the math here. Woo, good thing for Desmos. Negative 98 plus 360 is going to give us 262 degrees. So 262 lies coterminal with negative 98 degrees. Okay, now let's find a negative coterminal. So it's already negative. I'm just going to subtract 360. Negative 98 minus 360 is negative 458 degrees. Remember, there's infinitely many We just found two of them. One positive, one negative. So if you drew negative 98 degrees in the coordinate plane, it would lie coterminal with a 262 degree angle and a negative 458 degree angle. Okay, let's go to 475 degrees. Okay, we want one positive and one negative. The awesome thing is with 475, because it's so large, because it's such a high measure, I can subtract 360 and still be positive, right? Or I could add 360, it doesn't matter. I'm going to subtract 360. When I subtract 360, I get 115 degrees. 115 is still a positive coterminal measure. So if I took and in the coordinate plane, I drew 475 degree angle, and then if I took on the coordinate plane and drew a 115 degree angle, they would stop at the same exact spot. Okay? They are coterminal. Now, I need a negative measure. I subtracted 360 one time. Did it give me negative? No. So I have to do it again. So I'm going to take 475 and I'm going to subtract 720 degrees. Why? Because to find coterminal, you need to do multiples of 360. From 115, yes, you can. You could do that as well. Korea said, can't you just subtract 360 from 115? Yes, that's the same thing as taking 475 and subtracting 720. You get negative 245 degrees. What does this mean? If I drew 475 degree angle and then I drew a negative 245 degree angle, they would lie at the same spot. That's the idea of coterminal. Yeah, sure. Absolutely. Do you want me to do it with the negative 98 or the negative or the 475? Whichever. Okay, I'll do it with the 98. Okay, let me use purple. So let's draw a coordinate plane here. And our initial side always starts on the positive x-axis here. And I'm going to start with negative 98. So I know directly down is negative 90. I'm going to go a little bit past. I'm going to say 98 degrees. Okay, that's a little bit too much, but it's like not drawn to scale. That's negative 98. Okay, I went from the initial side and I went clockwise because negative measures go clockwise. Now I'm going to do a positive 262 degrees. So I'm going to start, let me go with a orange. I'm going to start here. Okay. I move 90, 180, and then I need 82 more degrees, which would land me here. So that is, this way is positive 262 degrees because it's positive. And so I'm landing there, lying coterminal, negative 98 and 262. They would be the same angle. They would have the same terminal side. Okay? All right, let's keep rocking. Here is the idea of what a reference angle is. Okay? What do I want you to write down? I want you to write down that very first sentence. For an angle theta in standard position, the reference angle is the positive acute angle formed by the terminal side and the x-axis. Okay, so that is your important concept of what a reference angle is. the angle formed is the positive acute angle formed by the terminal side in the x-axis. Okay, terminal side in the x-axis. That is what the idea of a reference angle is. So let me give you an example. Well, let me let you write that down, then I'll give you an example. Okay, let's say I drew a 165-degree angle in the coordinate plane. Okay, everybody sees it's 165 degrees. How far is 165 from the x-axis? How many degrees away is it? 15 degrees. Good job, Ben. So the reference angle is 15 degrees. How did Ben get that? Because he knows that the x-axis would form what angle? 180. So basically you say, how far away am I from 180? And that's the reference angle. Okay, let's do one more. I'll do it over here. Let's draw let's go 241 degrees. 241. So 90, 180. How many more do I need? 61 degrees. So 241. We'll go like right here. 241 degree angle. 241 degrees. Okay, so think. If you're at 241, and we know that x-axis is a 180 straight, how far are you from the x-axis? 61 degrees. Good job, Korea. 61 degrees is your reference angle. Remember, you're trying to determine for reference angle, you are determining how far you are from the x-axis. How far away is your terminal side from the x-axis? So always go back to that 180. Okay? Let's keep going. Determine the quadrant in which the terminal side lies and find the reference angle for each of the following angles. Okay, let's start with 102. Okay? Sometimes it helps if you quickly sketch it. Let's sketch it. A 102-degree angle is going to lie, let's see, that's 90, and then what do we need? 12 more degrees, so 102 is here, about. I know I go a little off, but okay, so that's 102. Which quadrant does that lie in? Second, quadrant 2. So this is quadrant 2 that it lies in. What would be its reference angle? How far is it acute angle from the x-axis? 78 degrees. Good job, guys. Very good. 78 degrees is your reference angle. Positive acute angle from the x-axis. Okay, number 9, or the next one, negative 400, we're going to do a little differently. My personal preference is to always get between 0 and 360 because that to me is easiest. Okay? I think that's what you should do as well. So let's take negative 400. Let's find a coterminal first. So let's add 360. Are we positive yet? No. We're at negative 40. What do we have to do again? Add 360 again. Where are we at? 320. 320. Yep. Ooh, look, I was about to put 230. 320. Okay, so we're at 320 degrees. What did that just tell us? Negative 400 lies coterminal with 320 degrees. Okay, let's draw 320. Draw 320. Okay, let's start. Positive x-axis is always your initial side. Okay, we're going to go counterclockwise. 90, 180, 270, and we need 50 more degrees. So we'll go like right here. We'll put our measure this way, Pac-Man, 320 degrees. Okay, which quadrant does the terminal side lie? Quadrant 4. It goes 1, 2, 3, 4. This lies in quadrant 4. Okay? What's that? Oh, when I did that? Oh, yeah. Sorry. 1, 2, 3, 4. So we land in quadrant 4. If we're a 320 degree angle, how far are we from the x-axis? 40 degrees. Very good. So your reference angle here is a 40 degree reference. You guys are killing it. Good job. We have one more concept to cover. So we did coterminal, we did reference angle, and now we have degree to radian conversion. And then we're done for today. Okay, this looks like a lot. Please do not write it all, okay? Honestly, you don't even need to write it. Let me just go through it. To be honest, you don't need it. It's just like, this is what a radian is. Okay, basically, you guys understand, like, in terms of measurement, you can measure things in different ways, right? I could hand Lauren a ruler and I could say, Lauren, measure that desk top in inches, okay? And she's going to give me a measurement. I could say, Valerie, here's a yardstick, measure that desk in yards. She's going to give me a measure, right? They're going to be equal, but in different units. That's what the idea of radian and degrees are. They're ways to measure angles, just different units. One's a radian, one's a degree. Okay, so let's practice with. You don't have to write anything here. We're gonna do some conversions. That's more important. This is just like, this is what a radian is, but it's more like, just for definition purposes. Okay, so here is what you need. How to convert between the two, okay? You will probably see on Monday, May 24th, when you take your EOC, a question that asks you to do a conversion, okay? Because that's a skill learned in Math 3. To convert from degrees to radians, you multiply by pi over 180. But you leave your answer in terms of pi. To convert from radians to degrees, you multiply by 180 over pi. So you have to know these two conversions. So take a minute, copy this down, and then we'll do some practice. How to convert between the two. This is our first time. But so we did when we were doing arc length and area of a sector, because there's formulas that use both radians and degrees. And so in my video lesson, I said that you guys already learned it, but I was like having a moment where I thought I already taught it. Yeah, I did not teach it prior to that lesson on arc length and area of a sector. But now you'll get the full, like, how do I convert between the two? Yeah, that was my bad. I was having a moment. I was thinking that I already taught you that, but I didn't. Okay, we good to go? All right, let's do some conversions. Convert each degree measure to a radian measure. Okay, here's how we're going to do that. We take the degree, we put it over 180, we simplify it, and then we put our answer in terms of pi. So we're going to go like this. Because we get to use Desmos, Desmos is beautiful. We're going to go to Desmos, and we're going to simply plug in 345 over 180. And then Desmos has this really neat little fraction button that you can press. So we're going to go 345 over 180. And look at this little fraction over to the side, 23 over 12. So our answer as a radian measure is 23 over 12 pi. Okay, so again, we put 345 over 180 into Desmos. We simplify, which gives us 23 twelfths, and we put it in terms of pi, 23 pi over 12. Next one, negative 510 degrees. I go to Desmos. Desmos is beautiful. Negative 510 over 180. I hit the little fraction button, negative 17 sixths. So my answer as a radian measure is negative 17 pi over 6. I mean, honestly, that's typically just how it's written, but you could just put it negative 17.6 pi. That's also correct as well. It just doesn't go at the bottom. It goes like next to or on the top. Good question. Okay, 150 degrees. Take 150. We could probably do this one mental math because we're smart. 150 over 180. The zeros cancel to 15/18. Divide by 3 top and bottom, and you have 5/6. 5 pi over 6 radians. Negative 240. Probably do this one in our head as well. Take negative 240, put it over 180. Simplify it. The zeros cancel. Negative 24 over 18. We divide by 6. Negative 4 pi over 3. Always radian measures in terms of pi unless it just says radian. And then there's no pi there. Okay, 600 degrees. Let's use Desmos for this bad boy. 600 over 180. Hit that little fraction button. 10 pi over 3 radians. 10 pi over 3. Okay, so how do we convert from a degree to a radian measure? You put the degree over 180, you simplify, and you put it in terms of pi. Okay, let's go radian to degree. Radian to degree. Radian to degree, you multiply by 180 over pi. Okay, so I'm going to go multiply by 180 over pi. What's going to happen to my pi's? Cancel. And you have 180 times 3, which is 540. 540 divided by 2 gives you 270 degrees. Seven pi over 6. I want to convert it to a degree measure. Multiply by 180 over pi. Pi's cancel. 7 times 180 is 1,260. Divided by 6 gives you 210 degrees. Seven pi over 3. Convert it to a degree measure. I take 7 pi over 3 and I multiply by 180 over pi. Pi's cancel. 7 times 180, we just did that, is 1260. 1260 divided by 3 is 420 degrees. Negative 11 pi over 30, we want to convert to a degree measure. Multiply by 180 over pi. Pi's cancel. Oops, look, I canceled the darn multiplication sign. Hello. Pi's cancel. Negative 11 times 180, we'll use Desmos. Thank you. Okay, and put that in parentheses, divide it by, what are we dividing by? 30, thank you. Negative 66 degrees. Negative 66 degrees. Beautiful. Okay, now I think we have a hodgepodge real quick. Convert from either radians to degrees or degrees to radians. Okay, letter A is a degree, 6.7 degrees. We want to convert it to a radian measure. 6.7 over 1, oops, I put 17. Hello, Amy. 6.7 over 180. Let's simplify that. 6.7 divided by 180. Hit that little fraction button. 67, ooh, wow. 67 over 1,800. 67 pi over 1,800. There's your radian measure. B is in terms of radians, so we want to go to degrees. We multiply it by the reciprocal, 180 over pi. 5.9 pi, we'll put it over 1, times 180 over pi. What happens? Pi's cancel, and we just get 5.9 times 180. Do that in the calculator, and we get 1,062 degrees. Letter C is a degree measure. We want to convert it to a radian measure. Negative 82.76, put it over 180. Let's do that in Desmos. Negative 82.76 divided by 180. Hit that little fraction button. Holy moly. Negative 2,069 over 4,500. That's a whopper. And then we got to put our pi. There's our radian measure. Let me ask you this. What is D given to you in? Do you see a degree symbol? No. So that is a radian measure. It is a radian measure. So we put it over 180 and put it in terms of pi. 7 pi over 180. We can't reduce 7 over 180. 7's prime. We're done. 7 pi. Oh, it's a radian. Oh, geez. Oh, my heavens. Amy, get your act together. I just told you it was a radian measure. Then I gave, oh, Lord. Multiply by 180 over pi. Thank you. Hello. It is a radian measure. So we put it over 1 and multiply by 180 over pi. Thank you. To get a degree measure. Because this is radians. I was having a moment. Ooh, that says radius. I don't even know what that says, actually. Let me. Radians. Okay, so we multiply by 180 over pi because it's a radian measure, and we want to convert it to degrees. So we're going to go 7 times 180 over pi. Where's my pi? Oops. Okay, so about 401.07 degrees. Approximately 401.07, and let me put a degree symbol. Okay, that is it for today. What you're going to be responsible for is go to Delta Math, and you have a very short assignment called 8.1 radians. I think that's what it's called, 8.1 radians. And go ahead and work on that. How many questions is it, Korea? 10 questions. Perfect. And it is 8:06. You have 39 minutes. Okay, that's you have till May 21st. Oh, it's 50 questions. You got it.